So as mentioned earlier, we'll be discussing about what is data warehousing and why it is implemented, what are the different types of service available, and what are the different types of architecture. And we'll be discussing more about OLAP. Okay, so let's get into the session. First, before we start the other concepts, we'll be just discussing about the basic concepts. Okay, so data warehousing just started when databases came into existence. But some might be thinking, okay, why do we need a data warehouse? So we have a database. In that case, why do we have to go for a data warehouse? Why can't we just do all the activities with the database itself? The major reason is the database is actually a place where the people who enter the data or all your transactions get updated. It is majorly used for operational purposes, whereas data warehouses has been used for data processing or information retrieval purposes. So data warehouse is used by the people who do data entry or who just code. Whereas in data warehouse it is used by analysts or people who try to retrieve the information from the data warehouse. Okay, so if you are just gonna give access to everybody from the same place, there's going to be a lot of activities happen at the same time, and it might lead to crashing of the system, or it might lead to data duplication or many other things. To avoid this, we are been following this kind of structure for a long period of time. Okay, that's how data warehouses came into existence. Okay, so as I told you, a decision support database actually is maintained separately from your organization's operational database. So this decision support database is accessed by BI or analyst experts, whereas this informational processing takes place on the decision support database, which is called as data warehouse. Whereas in the other database, which has been used for operational purposes, it's been accessed by a different type of people. Okay, the definition for data warehouse is it is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. Okay, so don't worry about these four terminologies of subject-oriented, integrated, time-variant, and non-volatile. We'll be talking about this in detail in the forthcoming slides. Okay, so when you say data warehousing, it is nothing but a process of constructing and using this data warehouse that you've created. So data warehousing is a process of constructing and using the data warehouses. Okay, so you'll be coming up on this kind of terminologies frequently. Okay, so let's see what is this definition means. First one is subject oriented. So when you say subject oriented, I mean, just take any organization for an example. There we will be having multiple databases of different context. We'll be having a data stored in terms of marketing, products, in terms of sales, and then in terms of finance, employee information, like in HR database. There's going to be too many informations, right? And different projects it has handled. So all the data warehouses will be able to store their data based on their subject. It will categorize it based on the subject. So like here example, I have customer information, product information, sales information, but all these things go together. Only the customer will be buying these products. So when they buy, that goes to the sales table. All these are little related to each other, but still it will be a different context. Okay, so all organizations store this data in this manner. Why they do it is because it gives us a very simple and concise view of all this data. So only with this, the organization will be able to retrieve information based on the context, so that they can take some decision. For example, I just want to know what are the customers who's paying us more, which means who's selling, getting more products from us. Okay, so if we want to find this out, I have to go to the customer table, right? For example, I just want to know which product is selling more. For that, I have to go for a product table, right? So based on the number of units, I can able to tell. So this is how we get this information. Okay, that's why we are able to store it in a very simple manner in based on different objects, so that we can able to retrieve it when we need it. Next is integrated. Yes, we have been storing in simple view based on the subjects, but still it should be integrated with each other. If we just have the customer table and product table separate and sales information separate, we really don't know which customer gave us how many sales. Right? We have to be able to integrate them together. It should be segregated based on the subject, but it should be integrated with each other. Okay, so when I say an organization data, it will be present in different forms. I've been talking about this even in a previous session. So I was saying when I was working as an analyst, I have to collect data from SAP tool. I have to collect data from the Workday for HR information. I have to collect data from different servers, different ERP tool for sales, right? So I have to collect data from different sources. So some with me in the of different formats. Some might be a CSV file, some might be a from SAP, some might be from a different database. So I should be able to collect all these different files together, and then I should be able to create a table or a database, and then I should be able to produce some reports. So it can be of different records. The type of the files will be different. The source of the files will be different. So, but you will be able to get this data, clean them, and then integrate them. So when we do that, we have to really check on the consistency of many things. Are the naming conventions same? So we have talked about this already. So sometimes the customer ID will be named as customer number, sometimes customer ID. You have to check on this when you're trying to integrate the data. Sometimes for example, I'm just selling cell phones. Some sales information will be stored in numbers, like one cell phone is sold or two cell phones is stolen. But sometimes they'll just buy it in packs. So one pack might contain 12 cell phones, so they just measure in one pack. So they just might say 1 2, which means 12 cell phones and 24 cell phones. So unit of measurement has to be consistent. It should be either in individual units or in packs, right? So all these things, information has to be consistent in all of the records. Okay, we have to check this. Okay, so when we are moving all this data by integrating this into a data warehouse, we have to check all this and then convert it if it is in a different format. Okay, next one is time variant. Yeah, so when you check the operational database, they just store only the current information, only what's happening in the present. Sometimes they may not have the information about the past. So all this information based on the timeline will be stored in your data warehouse. So if you are able to figure out what happened 5 years before in my sales department, you can just go to your data warehouse and then you can retrieve. But that may not be available in your operational database. They might store only information for just 1 year or 6 months based on the organization policy, right? Or based on the size available in the database. So when you have to look for a time variant, you always have to go for a data warehouse, because it actually stores a significantly longer information in compared to the operational databases. Okay, so it has an element of time always. Sometimes it is inform explicitly. For example, it might say what is this sales information for today, yesterday, date wise. You might have, sometimes it might just have it in months. So they are not storing that information explicitly. The date and time will be taken with the system automatically, though they don't have a date column separate, but you will be able to retrieve information for a particular month based on the entry, because the system automatically stores the date and time. Okay. Okay, next one, we're just going to talk about non-volatile. But before that, I just want to explain what is non-volatile and non-volatile in terms of data. So we've been talking about this in the memory point of view. When you say volatile memory, it's like, when your machine goes off, your data will be lost. Whereas when you see non-volatile, even if your power goes off, your machine will store your information. It's been happening in our machines recently, right? When you've been working on Microsoft Office tools earlier, when you were working on Word or Excel, and if you don't save it, when the machine goes off, it will like go automatically. Even the code, when you're coding, sometimes few ideas it happens, but it's not like that. Recently, your notepad and Word, everything. It's like what happens. Even if your machine just goes off without your knowledge, you're able to get back to that particular track, even if you have not saved it. So it is having a non. A few machines are having a non-volatile memory. So when you say non-volatile data, it is type of information which is stored in your file system, even if you have not saved it, but still, even if the power goes off and then it comes back, you'll be able to access that. So data warehousing is also a non-volatile system. Okay, you don't have to go and save it. If the data goes in there, it is there for always, unless you edit it or delete it manually. Otherwise, it's there always. Okay. So your physically a separate store of data is transformed from your operational environment to the data warehouse. So it's going to be there for always unless you update it. Okay. Okay. Next, we have to discuss about online transaction processing and online analytical processing. These are two types of processing which happens in your databases and data warehouses. Okay. So OLTP stands for online transaction processing. OLAP stands for online analytical processing. Okay. So who uses online transaction processing? The clerks and IT professionals, people who do data entry, they use OLTP. Whereas the knowledge workers like analysts, BI experts, data scientists, data analysts, they use OLAP. They use online analytical processing. So what do they function? What are the function they do? So these people will be doing day-to-day operations, so like storing information and accessing and checking the viability of the database and everything. Whereas in OLAP, these data analysts and data scientists, BI experts, what do? They help the management to take decisions. What they're supposed to do in the future, how they have to organize their business, everything. DB design, how it is how the DB is designed. It is based on application oriented. So if we are able to store the information little easier, they'll go for that particular design. Whereas here it is based on completely on the subject. If that makes sense for the business, they always look into that context. Okay, so data. In terms of data in OLTP, the data will be current, up to date, and it always very detailed. Whereas in OLAP, it has information from the past, from the date the people need it, and it always has aggregated information, and all the information will be summarized or integrated from different sources, and it will be there. Okay, processed information will be present for OLAP. So usage, I mean, OLTP, it will be done daily. So if I just want to want to know how many billing is done, so I can just do a query and daily query, and then I can just uh, ask it to run at a particular time, 12 o'clock on daily. Yes, it happens. It's repetitive. Whereas in OLAP, the request changes by the business. Sometimes they want to know who's the highly paid employee. Sometimes they want to know who's the employee who's been joined recently. The query is totally different based on the need of the business. So it's completely ad hoc. Access. Okay, so IT professionals here, they access to read, write, and do the indexing thing and primary key stuff. Whereas here, they don't have access to read and write and all. They just they'll be able to see the data and then access it. They cannot edit. Okay, what is the unit of work here? It is just it stores only the transactional data, so we'll be able to like give some query and check what's happening. The query will be very short and sweet. They just want to know what's in there. Whereas here it's going to be complex. So a lot of group by functions and other things happens here. Because I just want to know what is the sales of the particular city last week. So for that I can't just just give a direct query. I have to use group by. So I have to like group the data by city as well as by time, right? So here number of records accessed. So when you just want to like print the records, you just want to know like check the records. You just like print the first 10 10 or bottom 10 or middle 10 and then check it out here. But here you have to use millions of information because you're the person who's going to use all this things that has been stored, right? So you'll be accessing too many records. And the users here, there'll be a lot of people who's maintaining this database, but there'll be very few people who will be accessing it. Very few knowledge workers will be there. When compared to the database administrators, the analysts will be very less in number. Okay, and they'll be like paid more as well. And the DB size for them it's going to be very less because they'll be like taking care of only the current transactions, right? So for them it's less, whereas for the data warehouse it's going to be completely more because they have to store information for 10 years, 20 years. And the metrics here it is like transaction throughput, that is query throughput. So based on the queries you will be able to number of queries it's been done, you can able to find out. Okay, so we have been discussing this already, but still we are just going to discuss why you need a separate data warehouse instead of using your operational database. Why people have to go for a separate data warehouse? So we have DBMS, a relational DBMS, database management system, where OLTP happens. Online transaction processing happens on databases, whereas OLAP happens on data warehouse. Okay, so we have to go for a data warehouse because of different functions. For example, missing data information will be available. There'll be few missing data in operational databases, whereas in data warehouses it will not be there because they'll be having all the history as well. Okay, and data consolidation. I mean, you want to like integrate your data and work on something else so that you can just do some aggregation or integration or summing up, taking average. All these things is done only on data warehouse, not on the databases. And the data quality will be completely better when compared to the databases. So because of all these reasons, we should definitely have to go for a separate data warehouse. Okay. But recently, right now, there are lot of relational databases are having very good online analytical processing systems. So they themselves act as a data warehouses. Okay, so for example, you can say Microsoft SQL Server. So there you can just store multiple historical information, and then you can the reporting and querying systems are like kind of comparatively better. So things are kind of getting better, but still going for a separate data warehouse is recommended. So this is a sample multi-tier architecture for a data warehouse. So we have operational databases and few other sources if you are like having multiple sources of information, and then you do a ETL, extract, transform, load, and then refresh, and then store your data in the data warehouse, and then you have a metadata where you store all your database schema and data about your data and everything. It's stored in there, and then you'll be like monitoring all this, and then the data warehouse will be having a multiple data marts. It's for example, we said about like organization stores information based on the subject matter, right? Based on the sales, finance, HR. So maybe this is data mart which stores about a particular subject. Okay, so we'll be having a multiple data marts. So data marts are part of data warehouses. Okay, and then we'll be having the online analytical processing server. We have discussed that, right? And then on top of that, we'll be able to do some analysis, querying, reporting, and data mining into this data warehouse. Okay, so we'll be having a front end tools here to do this, and we'll be having an OLAP engine, and then we have a data storage and data source. So these are the four tiers of this multi-tiered architecture for a data warehouse. Okay, this is very, very important. You should definitely know this. Okay. So we just discussed about it. So this is the enterprise. There are three different data warehouse models. Okay, first one is the enterprise warehouse. There it collects information from different sources about different subjects and store. That's what we have been talking. And data mart is nothing but a subset of all this organization database data warehouse, where it contains information only about a specific function or specific project. Okay, so sometimes it can be like, dependent or independent of a data warehouse. Sometimes it is a subset of data warehouse. Sometimes it is completely independent. And virtual warehouse, it is like you're creating a set of views from your operational data. You're not creating a table, you're creating a views so that it gets updated whenever we need. Hope you heard of view when you work on SQL. I believe you worked on views. If not, try to create a view in SQL. Okay, so it's a virtual warehouse that you'll be like creating. Next one is ETL. So ETL, it's a very important terminology which has been like popular since the beginning, and there is a lot of job opportunities only for ETL. Okay, ETL stands for extraction, transformation, and loading. So what happens in this ETL process? So data extraction. The first step is data extraction, where we'll be like getting data from multiple sources, and this data will be completely different. It is in from different sources, and it will be different formats. And integrating them, it's going to be a very, very tough job. But before that, you have to like clean the data. As I told you, sometimes there'll be a lot of missing values. Sometimes there'll be like the name, the naming convention will be different, and sometimes the unit of measurement will be different. So we have to like look into that, and we have to look for the errors, and then clean them, and then we transform them based on the warehouse format for a similar format. That has to be done. And then we have to like we'll be able to load into that information. So if anybody has worked on Power BI or any of the other tools in BI, you'll be able to do all these things at the same time without coding. It's actually very easy. You can able to like import data from different sources. You can able to like clean them and transform them and load them. And then on top of it, you can just process the data and do some visualization or create tables. You can do some pivoting. All these things can be done. So if you or whatever that we have been discussing from you will be able to like experiment that in any of the BI tool. Okay, and then we have to keep the connection alive, so that whenever there is an update happening in your data warehouse, when you just click on refresh here, you'll be able to like collect the information there, and your visualization completely changes. For example, if you don't have, imagine you're doing a daily report of how many sales has been happening throughout the globe for one of the particular product, right? Just take some phone. So obviously there'll be like multiple phones sold over the globe for a particular brand. So I just created a report from my ERP by consolidating different data sources, and then I created a report. And then I have to do the same report tomorrow when the manager needs it. No, you don't have to do it. You just have to keep the connection alive. So when you just go and hit on a refresh button, this will be like automatically updated, and you can just schedule it. You don't have to go and hit the refresh button manually. You can just schedule it so that it get automated daily or weekly or per minute. And sometimes a live streaming data has a refreshing for at the interval of 4 seconds. Some tools has that. Okay, we can just keep it alive and streaming based on the requirements of the business, and based on that they have to invest. If it is like, they just don't need the information regularly, they just want to see the sales information only once a month, just doing it manually, that's fine. But if they want to see the information daily or every hour, we have to really go for higher investment so that the ETL gets automated. Okay. Next one is metadata repository. We just talked about metadata. We all know what is metadata. It's data about the data. So here we'll be like storing data information about data or about the data warehouses. So we'll be having a schema information, the views information, the dimensions, the measures, hierarchies, and everything. The data marks information, everything will be like stored in this metadata. Okay, whereas for a operational metadata, it's completely different, where it will be having a data about where the data is coming from and where it is kind of going, and it has only information of the units and error reports, trials, and everything. The schema, I mean the structure of the metadata in the data warehouse is comparatively different from the operational databases. Okay, because for a data warehouse it's a little complex, it's going to have too many tables, right, too many informations. Okay, so there will we have to look more into the schemas as well. So there the metadata has information about the algorithms that you're using and how the mapping is done, and it also like looks into the performance of the ETL path that's happening, and also the business data. I mean, what does it mean? What does the sales mean? What does marketing mean? All this business information. I'm just like giving a very layman example, but it gives more information about the product. So I might be having 200 products in my company. So it gives what each product does and what is the category it belongs. All these things it will have. Okay, so we just figured out the basics concepts of data warehousing. Then right now we'll be like talking more about data cubes and OLAP. Okay, so which comes under modeling, data warehouse modeling. Okay. Okay, so usually we used to like store our information in tables and spreadsheets. Right, we used to always see informations like jotted down in spreadsheets, right, in a table format. But a data cube is it's actually kind of a little different, where you'll be having a multi-dimension of this kind of information. You'll be able to like see different cubes where only one table or one spreadsheet will be part of that data cube, and you'll be having multiple tables or spreadsheets attached to a data cube. Okay, so why do we have to do this is because we have to create a multi-dimensional data model so that you'll be able to like process information the right way. For example, um, okay, I'll show you a structure, but before that try to understand two things which are part of data cubes: dimension table and fact table. So dimensions are nothing but the actual information. Mostly they are categorical in nature. It has information about your time, or I mean your date, and product information, all these things. It is mostly categorical in nature, whereas fact table, it has measures which is numeric in nature. It has information about your sales, price, number of employees, number of products sold. So these are measures, whereas the categorical information are dimensions. Okay, that's how they call it in BI platforms. Okay, in live BI platforms, in Tableau, in Power BI, they call it as dimensions and measures only, even in Click. Okay, so so any data cube will have dimensions and measures. Okay, so when you have a data cube, which is the base, it is called as base cuboid, and the top it is called as apex cuboid. We have discussed about that, but I'll be showing a small diagram little later so that where this apex cuboid and base cuboid will be there. We'll be just discussing in the later slides. Just know this terminologies right now if you didn't understand from a previous session. Okay, so just I'll show you a small example for a data cube. Okay, this is a small example. how data cubes looks like. Okay, here I have, you know, quarter 1, quarter 2, quarter 3, quarter 4. Okay, so here I have a home product category, home entertainment, computer, phones, security. So this contains a sales information for a particular product category for each of the quarter. Okay, so this is one dimension, whereas here I have, you know, locations: Chicago, New York, Toronto, Vancouver, and here I have a supplier information. So people who have supplied raw materials to manufacture the product for each of the cities. Okay, only one supplier for each of the cities. So this is one of the table, but it's part of a data cube. So here it has, you know, maybe a production information. We can just keep it as a production information produced for each of the quarter. But here this is based on supplier and city wise. Okay, so this is for supplier 2 and this is for supplier 3. Okay, this is how a data cube looks like. Okay, this is how, you know, a cube which is combination of a network of cuboids looks like. So for example, we just had time, item, location, and supplier tables. Okay, so when all of this like comes together, it is called a zero dimensional cuboid or an apex cuboid. It is at the top. Okay, so it has 4 different tables within it. Okay, so we can combine time and item. We can combine time and location, time and supplier. So item and location, item and supplier. So likewise, we are combining 2 different tables. Here we are combining 3 things. So time and item with location. Here time and item with supplier. Okay, so we have 3 information together. When I, like, you know, combine all this here, time, item, location with the supplier, we get all the 4 things together. So this is a 4-dimensional cuboid. So here I have 1-dimensional cuboid, 2-dimensional cuboid, 3-dimensional, and 4-dimensional. So when I get the 4-dimensional cuboid at the end, we call at the base it is called as a base cuboid. But when we have all the information together, initially it is called as an apex cuboid. So here we just have a, you know, a 3-dimensional cuboid. We had product information, time, location. Okay, sorry, this, we had supplier 1 as well. So for supplier 1 we have this. Okay, so a cube is nothing but a combination, a network of cuboids. You know what is cube and cuboid, right? Cuboid is a 3-dimensional view of a rectangle, whereas cube is a 3-dimensional view of a square. Okay, so now we have to, like, you know, work on the modeling of data warehouses. We're just going to talk about few schemas of a data warehouse. Okay, so for there are different types of schemas available. The first one is star schema. So here you'll be having a fact table in the middle, and all the dimension table will be like connected with each other. So you know what is a fact table? It's nothing but a table which contains the measures, the numerical information. Dimension tables contain information about the categorical information, right? So in star schema, a fact table will be present in the center, and which means the measures will be present in the center, and all the other things will be like present on the connected to that. Whereas in Snowflake, here dimensional hierarchy is normalized into a smaller dimension tables. So you'll be like, you know, forming a very small chunk of you know, uh, tables which has a dimension information. It's just like, you know, scattered around each other. So the structure is kind of like, you know, spread out. So that's why it is called as Snowflake schema. Okay. So there is other one called Galaxy Schema. So here there'll be like multiple fact tables with dimension tables. Okay, so this will be like more spread out when compared to the other two. Okay, that's why it is called as a fact constellation or galaxy schema. Okay, so this is a very three important schemas which is very popular for data warehousing: star schema, Snowflake, and galaxy schema. I'll just show you an example for each of these things so that you'll be able to like understand it very better. Okay, so here this is an example for a star schema. So I have all the fact information measures in the center. So time, item key, I mean the number, branch key, location key, units sold, dollars sold, and average sales number. All these three things are measures. Okay. So time key will be having a time information, day of the week, month, quarter, year. Okay. So branch information will be having branch key, branch name, and branch type. Item key will having information of the item number, item name, brand type, and supplier type. Location key will be having information about the street, city, state, or province of the country. Okay, this is an example of a star schema. Whereas Snowflake schema, it is the same. I mean, we'll be having the similar sales fact table, but here the supplier information is like kind of spread out here. You just have a supplier key, which have supplier key and supplier type here. City key has other information. So we just have street and key here. City key will have more information about city key, city, state or province, and country. So it's kind of more spread out. The dimensional table is kind of more spread out there when compared to the previous one, right? The fact table remains the same. Okay, so for galaxy schema, we have the same fact table. This all remains the same. Okay, whereas here we have a shipping table. So this information has to be present, right? For example, I'm a company, I'm shipping my products from my place to my customer. So obviously I'm going to have a shipping table. So I'm just going to have a time factor, which is going to be part of this, an item, a shipper key, which has one more table, shipper key, shipper name, location, shipper type. I might be like sending it through a different shipping company. So since I'm sending to different geographical locations, I'll be have to like tie up with different shipping companies from location to location. So it's going to be part of this location key table, and dollars cost and unit shipped. Got it? So obviously this galaxy is going to be schema is little popular and it's been used by current companies because there's a lot of when there's a lot of transactions or multiple functions involved, right? You understand? So we just saw the three different schemas available for data warehousing, and we saw an example. So I hope you were able to like understand this. Okay. So how that like the concept hierarchy looks like? A small example for that. So we just have all the information at the top. Then we have the regions, Europe and North America, and then the countries behind that: Germany and Spain, part of Europe; Canada and Mexico, part of North America; and cities of these countries: Frankfurt from Germany, Vancouver and Toronto from Canada; and the offices. I mean the street address for all these offices. In Vancouver, I might be having two offices. So this is how the concept hierarchy looks like. Okay. Okay, so there are three measures. I've been talking about measures, right? The numeric data. So how are these measured? Okay, so these are measured in three, computed and measured in three different ways: distributive, algebraic, and holistic. Okay, so when you say distributive, when you even take a small sample from the data, or when you take the whole thing, actually when you apply the function, it always remains the same. Okay, the count, sum, minimum, maximum. Okay, or the examples of distributive, whereas in algebraic, when you compute an algebraic function with this m arguments, each of which is obtained by applying a distributive aggregative function. So example for this is average, minimum, and standard deviation. And holistic, I mean, when you don't have a constant bound around on the storage size, you have to go for this holistic thing. So median, mode, and rank computation are example for holistic. Okay, these are how you can like compute measures. Okay, so this is how a warehouse and hierarchy looks like. See, you have a region here. So when you just look for the region information here, under Europe I have Belgium, France, Germany. In Germany I have Essen and Frankfurt, and then Spain, Sweden, UK. In Far West I had something information, and North America I have Canada, Mexico, United States. Under Canada I have Montreal, Toronto, Vancouver, and Vancouver actually have too many offices. Got it? So this is how the real hierarchies looks like in a warehouse. Okay, so this is how the multidimensional data looks like. I'm just going to give you small examples again so that it be in your mind. So this is how the multidimensional data looks like. I have a month information here, product information, and region here. So industry, category, and product, this is the hierarchy here. For region it is country, city, and office. For year it is quarter, month, week, and a day. Okay, so it's sample data queue with the dates. I mean, with the time information, we have first quarter, second quarter, third quarter, fourth quarter, and summation maybe the sales. So we have 4 sales, 3 product categories: TV, PC, and VCR. Sorry, it's not a product category, a product itself, and 3 countries. So we have a summation of all this. So this is how a data cube looks like. Okay, so we just talked about cuboids forming a cube, right? All from all your product, date, and country. So here we have product date, product country, and date and country, and then combine on here. The first, the 0-dimensional cuboid is called a vex cuboid, and the base cuboid is called as the final cuboid is the base cuboid. Okay, we're just like revisiting these concepts what we have discussed. Hope you got it again. Okay, so what are the operations which happens in the OLAP? There's a lot of online analytical processing happening, but still there are very popular ones that we'll be discussing. We'll be seeing the examples also right now. First we'll be rolling up, which is nothing but drill up. We'll be climbing up. We aggregate data together. Okay, we summarize data together so that we'll be able to see the whole information. To see the whole information we roll up, but we want to go deep down. We'll drill down and go to final information. For example, I just have a sales information for a particular year. I just want to know what happened in a particular day. I just drill down to quarter, I'll drill down to month, I'll drill down to weeks, and I'll drill down to a particular day. I can able to do that. It is very much possible in all BI tools. Okay, so that is possible, and then you can slice and dice. I can just try to find out what happened in a particular month for a particular product. You can I just want to know what is the sales of a particular product in for a particular day. I can dice as well. So dicing is you're trying to find out what happened to a particular product. Okay, and pivot, it is rotating, so you'll be able to reorient your cube. You can able to create your own pivot table with the information that you need, and you can just keep it forever. You can also visualize this table. Okay, you can even do that with Excel. You can connect you can do pivoting with Excel itself. It can be done very beautifully. We can just try to do it if we have some time. Okay, and there are few other operations like drill across. You can move across a different table from one fact table to other fact table, and then you can just drill across and drill through the bottom level of the cube. I was saying I just want to know what happened to a particular product which is sold by a particular employee, a sales executive, on a particular day. till that I can able to figure out. Okay, so this is an example for all these operations. Hope it is kind of little visible. I can explain this for you. So imagine this is a OLAP cube we have, and then you're trying to dice information for location, Toronto, and Vancouver. You just want for Toronto or Vancouver, but you want the items code. So you just want to know what happened to these items in the first quarter and second quarter in Toronto and Vancouver only, that you are able to do. So this is an example for dicing. Okay, so here you're trying to roll up. So you're trying to find out, here you have information for Chicago, New York, Toronto, and Vancouver, but you want it for I mean, these are cities in US and Canada. So you just want to combine these things. So you're rolling up. So we just have only 2 rows, only for US and Canada, not in city wise. That I can do. So here I'm trying to drill down, which means it is already in the quarters, but I just want a monthly information. The same thing, it is kind of like drill down on time. You can still go further for week information. I can see what happened all the 52 weeks, or a daily information that I can do. So here you're trying to slice the information. Here I just want to know what happens in the city for the whole year. I don't want a quarter information. Okay, and here still I can create a pivot table for this. Okay, you understood this? This is an example of what we have discussed in previous operations. Okay. Next one is StarNet query model. So sometimes people, it's kind of little confused about at what level I can go for a query. So to understand that, for example, I'm just having a few different tables here. So I have customer information, product information, organization, promotion, location, time, shipping method, custom orders. So for product, I have information of product item, line, and group. And for an organization, we'll be having, salesperson, he belongs to some district, and the districts belongs to division, and that belongs to whole organization. So for a location, you have city, country, and region. So sometimes if you want to get information about few things, I don't know whether I have to get it at a city level or a country level. I don't know whether I get it from a salesperson point of view or a district point of view. You do not know that, right? When somebody asks for information, so you can just create a StarNet query model. So if I've been asked information based on a salesperson, I can just go salesperson, product line, contracts in this schema. So you can just, if you have the instructions clear, you can just go and do the querying. But if you don't, you can just, look into this, query model, and then you can decide. So it is called as a StarNet query model. Okay, so it's just, a sample show of how a data cubes look like. You don't have to think all the data cubes will be formed earlier. A few data cubes will be created, but few data cubes will be created based on the need. If it is very important, that information will be created and kept. Otherwise, it will not be available. For example, here I can just see here I have the location and product information, and we have revenue. So I have 3 different product categories. For 3 different product categories, outdoor products created a revenue of this much. And for the location, I have to go for this data cube. So it's been calculated and kept like this. So this is how it looks like. Okay. Hope you're able to imagine this and figure this out. So we just talked about modeling and OLAP cubes. Now we'll be talking about the data warehouse implementation, how we can able to implement this in an organization. Okay. So efficiently working on this is very much important. Okay. So as you all know, so that data cube is a combination of cuboids, right? A network of cuboids. So the bottom cuboid is called as a base cuboid, and the top cuboid is called as the apex one. So if you want to know how many cuboids are present in your data cube, We can compute that based on the formula. Pi multiplied by L plus 1. So L is nothing but your levels, and N is nothing but your number of dimensions that you have. So with that, you can calculate how many cuboids that I can have in my data cube. Okay. So it is, as I told you before, it is completely unrealistic to compute and keep all your data cubes with you. But if you need, you can always go and compute. So how to materialize this data cube is like, first, sometimes, you materialize everything, which means you compute all the data cubes and then keep it alive. So that is called as, full materialization. And there is something called no materialization, because there is, you don't compute anything based on the need. You just compute. You don't pre-compute anything and then you materialize and store it. There's something called partial materialization. You just like, compute very few things and then keep it and store it. Okay, so you can just like, based on the, need, the frequency and the usage, you can just do that. So most of the times, based on the in organization, what happens is like they have a reporting structure. They always know what do they need. Okay, so accordingly they create a data cube and keep it alive, and they get this information from that. And very rarely they get some ad hoc reports, ad hoc request. So at that time they go and create their data cubes, and if they think, if the analysts think they're going to get this kind of request again and again, they'll keep it. Otherwise they'll destroy that, because it's going to save their space, right? Because that's what I've been doing. So computing this, cube. So for example, we'll be having a cube for sales. We'll be having a what we have to do is like product and all. So first we have to like compute a cube for sales. First we define what are the columns, I mean variables that we're going to have, and then we keep it. And then for a product we can do the same thing. Okay, and then if you want to like, operate it, if you want to add few things. For example, here we just had item, city, and year, and sum of sales, right? So this is the cube that we have defined. And then if you are selecting it, you can just, select that. And then you want it in that order, you can just, create a cube by this. So this is how the thing looks like. Okay. So for this, you can like, do a group by based on the date, product, or based on the customer, or in this combinations as well. We are able to like, understand SQL. This is like, very, very easy, right? And indexing is a very important thing in OLAP. So we will be like, doing indexing in many methods, but bitmap and join indices are like little prominent. So here you have a table, we have a customer ID, region, type. So we have a region, and then the type of the supplier. So for example, for Asia, the ID is like, created as 0100. For Europe it is 010, and for America it's 001. So whenever you get the customer like this, it's been like, index like this. For a retailer or dealer, for retail it is 10, dealer it is 01. I'm just indexing it here based on this. Okay, so here we call that as a vector, bit vector. So this length of the bit vector is equal to the number of records we have. Okay, so we have like 5 records, so we have like, indexing 5. We'll be like indexing based on the records that we have here. For join indices, it's a similar thing, but it join index relates the values of dimensions of the start schema to the rows in the fact table. So we have the fact table here. So it relates the values of the dimensions of the start schema to the rows in the fact table. So here we can see the sales in 2 dimensions, city and product here. A join index on city maintains for each distinct city, and then you can see it can like span on different dimensions as well. For main street, sales, and then an item. It goes on for 3 different things. because we have like, three, it is from three different tables. Okay. So how do we like, process this OLAP queries very efficiently? It's very, very important, right? Because we have been talking about all these queries that we have been doing earlier, drilling down, slicing, dicing, everything. How can we do it very efficiently? First, we have to determine what kind of operation should be done, and what are the cuboids that we have. So we have to like the person who's like, who's internalizing these things has to know what data they have and what format it is in and what kind of cuboids they have and what do they need. So they have to think through this, and then they'll be able to like, understand what kind of operations they do, and then they should be able to like, code it in SQL in that way. Okay. So SQL, most of the time it is done through SQL, but if it is not, if you're using any BI platforms, you should know where to go, what are the informations that you have, and which table it is present, and where I have to go and drag and drop, and what kind of, visualizations I should be able to do. Okay. It's actually based on the team's efficiency or the analyst efficiency, how brilliant he or she is. Okay. So we have to determine which materialized cuboid that we have to like, go and select. For example, if you have to like, find information for brand and province location information for the year 2004, we can either go from year, item name, city, cuboid, or year, brand, country, year, brand, province, item name, province, where year is equal to 2004. But which has to be like, selected for the query. That we have to really, really find it. So we have the brand here and here. Maybe if we can go for this, it's very easy, right? Instead of like, combining these two things, we can just, go for this where we are equal to 2004. It's very easy, right? So it's actually about the person who's doing the task. Okay. Okay. So the final thing is like, there are different OLAP server architectures available. Okay. Relational OLAP, so it's nothing but your relational database management system or extended RDBMS that you have. So where you'll be having your uh, data warehouse as well as, OLAP middleware, and then you can just go and do all your things. So either you can go for a relational OLAP or multi-dimensional OLAP. It is called MOLAP. So here actually you'll be having a data stored um, through sparse. Okay. So it's sparsely arranged, and it is kind of like easy to index and then create a pre-computed data cubes and store when you go for this multi-dimensional OLAP. But we have a hybrid OLAP, so it is combination of relational and multi-dimensional OLAP. So there we'll be able to like, create data cubes, and that is a kind of little faster. You can scale it better like your relational OLAP. So my hybrid OLAP is kind of, frequently used. You have Microsoft SQL Server. It's a very good example for hybrid OLAP. And we have very specialized SQL servers based on the need of the organization. You'll be able to like, create your data warehouses according to your need, and you can customize. And then you can go for Redbricks, and a very good example for a specialized service. So these are the four different kinds of server architectures available in the market. Okay. So I've been like, working on Microsoft SQL Server extensively, which is very, very cool. And you can able to like, work on your needs very sophisticatedly when compared to the other architectures available. Okay. So we have been like, discussing on too many things. Today we talked about what is data warehousing and why do we need it, what is data cubes and how to construct that. We have been talking about from very basic concepts to the advanced level. We talked about how to implement this, and we talked about how to model data warehousing in terms of, OLAP and many other things. If you got any doubts, we can just discuss. Okay. I think you're able to understand this. Are you able to understand these things?